Hello everyone. In this lecture, we are going to study about superposition theorem. Superposition theorem states that in any linear bilateral network having more than one source, the response across any element is equal to the sum of responses caused by individual sources separately, while all other sources are replaced by their internal resistance.
Steps to solve superposition theorem is shown here. Step 1 is to take one independent source at a time and deactivate other sources. We take one independent source at a time because superposition theorem talks about finding response on an element caused by an individual source at a time. Deactivating other sources mean that the sources are replaced by their internal resistance. When there is a voltage source, it is replaced by short circuiting, and when we have current source, it is open circuited. Depending upon the number of sources that are available in a circuit, step 1 is to be repeated. So step 2 talks about repeating above step for each source. Step 3 is to determine net branch current by getting the values from step 1 and 2. If the direction of current is similar, then we add up the results that are obtained. While if the direction of currents are opposite, we subtract the values of response that we get. This is the procedure for solving a numerical using superposition theorem. Let us go to a numerical. Here we have a question that says find branch current in 8 ohm resistor using superposition theorem. We need to find the branch current flowing across 8 ohm resistor. When we need to find current flow through 8 ohm resistor using superposition theorem, we find that there are two sources given in the question. One is a voltage source of 20 volt and a current source of 2 ampere. Case 1 will state about finding current flow in 8 ohm due to voltage source of 20 volt. Case 2 will talk about finding current flow through 8 ohm because of a current source of 2 ampere. The final step will be adding up the amount of currents formed from step 1 of 20 volt and step 2 of 2 amp. Adding up the results give the total net current that is flowing through 8 ohm due to both the sources that are available in the given circuit. Let us have a look at the numerical. So when we consider voltage source of 20 volt source only, 2 amps current source is replaced by its internal resistor, that is, it is open circuited. So no current will be flowing through this loop as it has a broken path in them. So current flowing through 8 ohm resistor will only be due to current in loop 1, that is I1 dash. The value of current will be obtained by applying KVL equation in this loop. So on applying KVL, we get 2 into I1 dash plus 8 into I1 dash minus 20 is equal to 0. We get such an equation, and on solving it, we get value of I1 dash as 2 ampere. Let us go to case 2, where we need to find the amount of current flowing in 8 ohm because of current source of 2 ampere. Voltage source of 20 volt is short circuited here. So if we need to find the amount of current flowing through 8 ohm, it will be because of both I1 double dash and I2 double dash currents flowing through 8 ohm. We have two loops in the question. So from circuit, we can straight away say that current flowing in loop 2 will be equal to 2 ampere. We need to make note of the direction of the sign convention for I2 double dash we have assumed and the direction of current source given. Current source flows in this direction while our sign convention of I2 double dash we have assumed is in this direction, which means the directions are opposite. So value of current I2 double dash will be minus 2 ampere. Value of I1 double dash can be obtained by applying KVL in loop 1. While applying KVL, we can get equations like this is 2 ohm, not 2 ampere. So this will be 2 into I1 double dash plus 8 into I1 double dash major current minus neighboring current I2 double dash. Minus is because I1 double dash enters in the resistor while I2 double dash enters in the opposite direction of 8 ohm. So we get an equation like this, and on solving this equation we get 10 I1 double dash minus 8 I2 double dash is equal to 0. We already know the value of I2 double dash as minus 2. On substituting this value, we get value of I1 double dash as minus 1.2 ampere. So we have the values of both I1 double dash and I2 double dash for the circuit. So the net current flowing through 8 ohm will be difference in the two currents because of the opposite directions of the current that is entering in 8 ohm. That will be equal to minus 1.6 plus 2 amp, which is equal to 0.4 ampere. The last step is to find the total amount of current flowing in 8 ohm because of both the sources, that is a voltage source of 20 volt and current source of 2 ampere in the circuit, which will be equal to 2 ampere plus 0.4 ampere, which is equal to 2.4 ampere.